My name is Takeharu KATO. I'm a senior engineer in Linaro. I'm here to talk about orchestration work for HPC systems with Ansible. It's a part of compiler lead project in HPC. Renato and I will talk according to this outline. At first, we explained what OpenHPC is briefly, and next I'll explain what is the core problem core problem around the orchestration of OpenHPC. And next, I explained what Ansible is and the reason why we use it. And next, I'll show the current result of our work. And last, we explained future work. Would you please?
Okay, sure. So I think most of you know OpenHPC is packages in one side, but also the recipes in the other. And thanks. And just the packages is the easy part. The problem is the recipes. They go into a document, and then we have to comment out things or run things by hand on, and it's really not. In the end, everybody setting up a cluster have to either remove lines from the script or add lines to the script, or and so it's not a big. So that's a problem, right? It's not a big deal because you do this once and then you just set up all your cluster many times. But if you're not setting up many times the same cluster, if you're actually setting up different clusters, or if you have a matrix job that needs to set up, too many times in different ways, it starts getting very complicated to, you end up hard coding a lot of scripts, and that's never a good idea. So what we have is the recipe is in the document, so it's a LaTeX source code that has this thing, and that's when you render this as a PDF, it actually prints this as a nice box. But there's a script that then parses this same thing again and dumps into a shell script, right? And then you get this, well, this is not the same line. I should actually have copy and paste the same line, but this is, these lines, so this install thing ends up being yum minus y install, because if it's SUSE, it's a different thing. So the problem is the scripts are generated from the documents. And then, which is okay whenever you change the document, you change the scripts, but the scripts are not tested as scripts. They're just dump off a document. And then if you want to use the script, you have to change it by hand for every little change that you need. And if you need to do this for like 2 or 3 different clusters, now you have 2 or 3 different scripts. Then when there comes the new OpenHPC document, well, you have to change your scripts again. And that doesn't scale. And if we, in our lab, we have to test a matrix of jobs, so like CentOS, SUSE versus different vendors, different interconnects, and different, because part of the description is about how you set up the network, how it's configured, what goes through like 10 gigabit or InfiniBand or gigabit. So there's a lot of and IP ranges and node names. So all of these things can change depending on the size of your cluster, and it's just, it ends up being a huge list of hard-coded scripts, right? And there's also this input.local file, which then sets up some bash environment variables, and then now you have all the problems of propagating environment variables through different scripts, and it's not really. Oh wow, I just said everything about this in this slide. The other big thing is that the recipe.sh is not idempotent, which means if you run it twice, it destroys your system. So I had an attempt last year to make it so by adding if grep the expected result in this file, if it's not there, then do the change, but that's not good, because then if for each one of the changes you have to have an if, but for a large number of changes you have to have another if, because the changes are not, they depend on each other. So you change a file, then you restart a service, then you change another file, and then you restart the second service. But if you've already done the last step, then you don't want to try to change the file again. So it ends up being a huge nightmare. And it exports the shell variables, which then you have to pass on to the other scripts. And extensibility is impossible without editing the file. It's either has everything or nothing, and it's really not nice. So that's why we're doing the. Is this my slide? Or, oh yeah, there you go. This was my attempted solution. So I split. First is one shell script that does everything. And sometimes you just want to run the first one to see everything's okay, then you run the second one, you see that everything's okay. So I try to separate into like base install, which installs the packages, then master packages, we just install the SMS configurations, then the network provision, and optional, which this is the script that I never needed, so I just called it optional. Master files, and then the bootstrap, which then creates the VNFS image that will be pixie booted into the compute nodes. But again, I've done all of this, and it works for CentOS. But if I wanted to do SUSE, I'm gonna have to have a different tree altogether, and that just doesn't scale. It doesn't work. And this is the real question: why am I trying to reinvent something that already exists? Right, so this is why we started with the, oh, there you go, that's your slide. So why are you trying to do this? And then, and in Fujitsu, you guys are already using Ansible, right? And so then, well, let's do the right thing. And that's where the KATO-san's work started.
Thank you, Renato. And the core problem on the orchestration for OpenHPC is lack of configuration management system. OpenHPC has no configuration management system. In general, generally, a configuration management system treats different nodes, different type of nodes, and configure various network infrastructure properly. But OpenHPC has no configuration management system, so current recipe.sh can manage the diskless cluster only. But nowadays, and today, many various cluster structure are used in HPC world. So we decided to Ansible to install OpenHPC more easier. Ansible is a simple automation. Ansible is a simple automation language which can describe the structure and the configuration of IT infrastructure with simple YAML format. It's called Ansible Playbook, and the reason why Ansible is the best solution for OpenHPC deployment it's the most promising CMS tool now, in particular in server management area. Many people in server administrators uses Ansible, and Ansible playbooks are idempotent. It is a crucial property for proper orchestration, as Renato mentioned before. And at last, Ansible can manage nodes tasks according to the structure of the cluster. It needs to manage the current huge variation of cluster structure. And so I think we think Ansible will be a mainstream in deployment for servers. So Ansible is the most reasonable solution for HPC clusters. And next, I will explain some improvements from recipe.sh. It divided into three things. First, we can configure where packages are installed according to the node type. And we can, second, we can replace the installation process at many times. Ansible has an idempotent. It's very crucial thing because sometimes some nodes will may down during installation phase. HPC because HPC cluster is very huge. Typically, HPC cluster is very huge, so very large. So it's important property. And last, we can adapt the same recipe for various HPC systems: Intel, AX64, and bare metal cluster, cloud, and container. And our current result, simply speaking, it can reduce installation time to install OpenHPC. We took a week to install OpenHPC by hand before, but now we can install OpenHPC in 3 hours. And next, I explain the current status of our work. And now we ported recipe.sh to Ansible playbook and Ansible playbook. Our playbook does not depend on HPC specific tool like Werewolf or XCAT. So the playbook could be applied to other tasks with minor changes. It may be useful for other leg task. And we are testing now. We are testing on x64 machines, but of course, we will test it on AX64 soon. And we try to rewrite our playbook for common use. We try to divide our playbook into Ansible roles for each package. Ansible role is a unit of the installation tasks. So it might be useful for common use, and it is needed to upstream our installation task to OpenHPC or Ansible Galaxy. Ansible Galaxy is a community website for Ansible. There are various installation recipes in the recipes, and many people share their recipe playbook among the through the site. So it is I think rewriting Ansible playbook for common use is a very important task. We are concerned in this task now. And at last, of course, we we will collaborate with OpenHPC community to make OpenHPC installation easy. So we would like to upstream our playbook to OpenHPC community. And anyway, we would like to publish our playbook and upstream our work to OpenHPC and Ansible community. We will start this task from next month at earliest. Next, I show a screenshot of OpenHPC installation phase of OpenHPC. This screenshot indicates Ansible can handle the type of nodes properly. This slide it indicates Ansible installs SLAM server on the master node only. Before recipe.sh or other way to orchestrate this package installed all nodes in the cluster. On the contrast, Ansible can handle types of nodes properly. This is very important characteristic for orchestration. The next screenshot indicates a test phase. Now we are test the cluster by hand, but we try to write another playbook to run tests automatically. After this, we can apply this playbook to Linaro labs, and we can test the compiler and libraries and middlewares automatically. It's crucial for, I think it's crucial to make SV compliant compiler more useful. And next slide, I explained the part of our feature work. Now we are engaged in the functions which are covered by OpenHPC, CentOS plus Werewolf and InfiniBand, Raster, BGFS client. But we would like to expand our approaches to other HPC software, like supporting various operating systems like SUSE and XCAT installer and various type of Ethernet and Raster and BGFS servers. As we think Ansible will help to support various packages, devices, OSs in HPC. And feature work, I think our feature work divided into three parts. One of them is improving maintainability. As Renato mentioned before, current OpenHPC recipe is recipes generated from LaTeX documents, but now we are port the recipe.sh to Ansible playbook by hand. It is not so good for maintainability. So we we should consider to increase maintainability. For example, considering the way to generate the playbook from the document, like current approach. And next, we would like to make Ansible more popular in HPC world. And third, we would like to make writing site-specific configuration easier.
Oh yeah. So this is one of the things actually that Baptiste is working on. So what was this again? Right. So the thing is, we want to test a grid, like a matrix of things. So different vendors, different networks, different OSs, different. So it's like a multi-dimensional kind of grid that we need to test. And for this, we need a provisioner, and a provisioner that can give us a way to put like a different kernel, different init.rd image, different kickstart file for each one of these jobs, and then run the OpenHPC Ansible in different ways. So some of the job is in the provisioner to say, look, flash this kernel with this OS, SUSE, CentOS, or whatever. Or flash the ERP kernel, or the CentOS upstream kernel, or the SUSE upstream kernel, and see if they behave differently, or if this is part of the matrix. And that needs the, the provisioner. But then you run the OpenHPC, and you say, well, now that I'm on CentOS, and I want InfiniBand, and etc. So the job dispatcher has to know all of this configuration and which level to ask for these kind of things. But then there's the third stage, which is, okay, now the master is set up, we need to boot the slaves and make sure that the master can provision the slaves in the right way, which means the provisioner that provisioned the master cannot respond to the slave's PXE request. So, and if we have a dynamic range of slaves, now you need the provision to be smart enough to be dynamically set up and to work with the Ansible scripts in a way that Jenkins can say, this is the range, this is the OS, this is the OpenHPC setup that I'm going to run, install and run the test suite. So this is another part of the work that we're doing. So for instance, one way would be if we had a VLAN, if we had a way to configure the switch dynamically to set a VLAN, so we don't need to change the DHCP server to not respond to specific MAC addresses, for instance. Right, so it's not, we don't yet have a great answer for this, because we're going to have to try and fail until we succeed and say, okay, this one works. Right now we're only failing, so when we succeed, I will let you know. Yeah, I mean, force the master, so you can tell the master only answer to this MAC addresses, but then you also have to tell the top level provisioner to not reply to this MAC addresses, or you can say to the master only to reply to the master's MAC address. So it's something that, because our requirement is slightly different. If in your company you build a cluster, you build a cluster, done, right? Here we're trying to build multiple clusters dynamically, so that has a slightly different kind of requirements. So this is the other part that we're trying to do, like get an ERP kernel and boot into a machine and see if we can get a system out of it, and then try to make that dynamically. So that's how's the, you're doing that in Ansible as well, right?
Yeah, all the provisioning via Mr. Provisioner is automated via Ansible.
Yeah, nice. So the Jenkins just runs an Ansible script, which then talks to the provisioner, and then once this is provisioned automatically, there's another Ansible script that would then set up, and then another Ansible to install OpenHPC, and then another Ansible playbook to provision the masters and the slaves and everything. So yeah, we like Ansible. We want to Ansibilize the world. Is that, yeah, that's the last one. Any questions, or you guys hungry? Right, thank you.